Welcome students. In this video I am going to explain about shortest job first and remaining shortest job first, preemptive and non-preemptive versions of this algorithm in CPU scheduling. Here we have first non-preemptive version of shortest job first algorithm. It's a scheduling policy that selects the waiting process with the smallest execution time to execute next. So here the catch here, smallest execution time process will be allocated to the CPU. Here is an example for non-preemptive shortest job first algorithm. Here we have four processes, process 1, 2, 3, 4 and execution time. Process 1, 6, 8, 7, 3 for process 4 and arrival time is also given. Here we have to build a Gantt chart first. So here the smallest process within the given processes, the smallest process with an execution time is P4. Here 3. Among these processes, P4 is the smallest process will be executed first. So P4 will be given the CPU first and it start executing. After completion of P4, now the arrival time here is 3. Now the next smallest process here is 6, which is P1. P1 will start its execution. After the completion of P1, then the next smallest process here is P3. So P3 will be executed next, and then the last final one with the largest CPU execution time will be given the CPU next. So this is how the order is going to given. The smallest execution time, the process with the smallest execution time will be allocated to the CPU. Now we have to find the waiting time here. We assume that all the processes arrival time is 0. So here the process 1's waiting time is 0, process 2's waiting time is 3, process 3's waiting time is 9, process 4's waiting time is 60. So we have to find the average waiting time. So here average waiting time is the sum of all the processes divided by the number of processes. So it will give the value of 7. So here we assume that arrival time is 0. Now we have an example. In exams we don't have this easiest question. So in the exams the arrival time will be given and we have to find the average waiting time of each processes. Now this is the previous year exam question in net exam. Now we have to find the average waiting time for this given question using the shortest job first, non-preemptive version of shortest job first algorithm. Now we have to find the average waiting time of each processes. I'm going to build a Gantt chart first. So we start with 0 here. We start with 0. The first process is going to arrive here as P4 with the execution time of 3. So it will be given the CPU because it arrives first. Okay, since this is a non-preemptive scheduling algorithm, P4 won't leave the process until it is completed. Okay, at the time of 3, arrival time is now the process execution time is 3. At the arrival time of 3 we have two processes, P3 and then P1. Among these P1 and P3, among these the smallest process here is P1 with the execution time of 6. So process 1 will given the CPU. At the time of 3 we have two processes, P1 and P3. P4 is already completed. So the smallest process among these is P1. So it will given the CPU. It run for 6 nanoseconds. So 9. Now it is completed. P1 is completed. P4 is completed. Now we have P2, P3 and P5. Now at the time of 9 we have all the processes. Among these the smallest process here is P2. So P2 is given the CPU next. So P2 will run for 2 nanoseconds. So 9 plus 2, 11. Now P2 is also completed. Now we have only P3 and P5 left. Now we have only P3 and P5 left. Among these, P5 is the smallest process with the execution time of 4. So P5 given the CPU and it will run for 4 nanoseconds. So 11 plus 4, 15. Now the leftover process is P3 and it will given the CPU and it will run for 8 nanoseconds. So 15 plus 8, 23. Now we have to find the waiting time of each processes. Waiting time of each process. Here arrival time is given, so we have to subtract the arrival time from the execution time. Here first we have P1. P1 starts executing at 3rd nanosecond. So P1 execution time, start execution time is 3 minus 2 is 1. This is the waiting time. P2's starting point of execution is 9th nanosecond. 9, it started its execution at 9th second, so 9 minus 5, 4. And then P3 starts its execution at 15th nanosecond and its arrival time is 1. 15 minus 1, 14. And then P4 execution time is 0, starts execution time is 0 and its arrival time is also 0. So waiting time is 0. And then P5 starts its execution at 11th nanosecond, so 11 minus 4, 7. So this is the waiting time of each processes. Now we have to find the average waiting time here. 5, 19, 19 plus 7, 26. 26. This is the sum of all the processes waiting time. 26 divided by number of processes 5 will give you 5.2. 5.2. So this is how we have to find the average waiting time by using non-preemptive shortest job first algorithm. Now we have another version of shortest job first algorithm, which is preemptive shortest job first algorithm. Here the problem with this preemptive shortest job first is we have to make sure that we have account of number of processes and their runtime in each second. So here it's a scheduling policy that selects the waiting process with the smallest execution time to execute next. Here, even if the process is running and the number and then the arrival process is with the smallest time, then the smallest process will be given the CPU. Now we are going to remove the running process from the CPU and we are going to give the CPU to the smallest execution time process. Here an example, the same example we are going to use to demonstrate remaining shortest job first algorithm. Here the same Gantt chart with, one second. Okay. Yes. Now here we start at 0. We start at 0. At 0th second we have no processes. We have no processes. Here P4 is the only process here. So P4 is given the CPU at the time of 1. So here at the 0th second we have only P4 with the execution time 3. Okay, and at the time of 1 we have P3 here. At the time of 1 we have P4 and also P3. Now P3 execution time is 8, larger than P4. So we are not going to preempt any process here. So P4 will run for another second, and then at the time of 2 we have P4, P3 and P1. Now we have again P4, P3, P1. Among these the smallest execution time is P4, so it will run. So it will run for 3 nanoseconds and it will complete its execution. Okay, P4 will complete its execution. At the time of 3 we have P1, P3 and P4. P4 will complete its execution. So among these P3 and P1. Among these P3 and P1 the smallest process here is P1. So P1 will be given CPU. So it will run for 1 nanoseconds because at the time of 4, arrival time of 4, we have P3, P1 and then P5, and then P5. P5 with the running time of 4. This is the smallest among P3, P1 and P5. So P5 is given the CPU and P1 is removed from the CPU. And then P5 will run for 1 nanosecond. P5 will run for 1 nanosecond because at the time of 5 we have P2. P2 arrived, so we have P3, P1, P5 and then P2 with the execution time of 2 nanoseconds. So you can see P3 with a running time of 8, P1 with a running time of 5. We already run 1 second, so 5, and then P5 with a running time of 4. P5 with a running time of 3 seconds, and then P2 with a running time of 2 nanoseconds. So P2 will given the CPU and it will complete its execution. Now here we have all the processes arrived, and here P4 and P2 completes its execution. Now we have P1, P3 and P5. Among this, the smallest process here is P5, and it will given the CPU and it will run for 3 nanoseconds. So 10. Now P5 is also completed. P2 is also completed. P5 is also completed. Now we have P1 and P3. P1 with the execution time of remaining 5, P3 with the execution time of 8. Now smallest process here is P1 and it will be given the CPU and it will run for 5 nanoseconds here, 5. So 15. Now the next process here, P3 with the 8 nanoseconds execution time and it will run for 8 nanoseconds, so 23. Now we have found out the Gantt chart. Now we have to find the waiting time of each processes. So P1 here. Now we have to select here. We are not going to select the first execution time. We are going to select the last starting point execution time. We are not going to see in this Gantt chart. You also see P3 starts its execution 3 and removed from the CPU, and again P1 starts its execution at 10th nanosecond. So we are going to select the final starting execution time of each processes here. P1 starts its execution at final execution time is 10. Among these 10, process also runs in 1 second. Among these 10, process 1 also run for 1 second. So 10 minus 1 minus arrival time 2 will give you 7. Okay, this is the waiting time of process 1. And then process 2 final execution time is 5 here, and its arrival time is also 5, so 0. And then P3 starts its execution at 15th second. Before that P3 won't run any time period, so P3's starting time is 15 minus 1, 14. And then next P4 starts its execution in the beginning 0 itself, so 0 minus arrival time 0 is 0. Now P5 here, P5's final execution start execution time is 7, and within that 7 nanoseconds P5 already runs 1 nanosecond, so 7 minus 1 minus 4, so it will give you 2. It will give you 2. So we have to find the sum here. The sum of these processes here is 23. So the total number of processes here is 5. So 23 divided by 5 will give you 4.6. So this is the correct answer. So this is how you have to find the average waiting time using remaining shortest job first algorithm. In the next video, we will see priority scheduling algorithm. Thank you.